Welcome back. This is lesson 3 of week 7, and in this lesson we'll look at how you tackle questions where you're presented with a real life example and you have to turn it into a logical expression. So we'll look at 2 case studies, one based on cryogenics and one on a rocket launch. Cryogenics is the study of preserving life using freezing. This is an example from a science fiction film. It's not real yet. So imagine that a cryogenic tank is monitored by 3 circuits, 3 sensors. An alarm is triggered if either of the following conditions are met. A is on and B is off, or B is on or C is off. Find out all possible combinations of sensor signals which could trigger the alarm. So it's pretty obvious here, A, B, C are the inputs and X is the output of the circuit. So A, B and C can be in all different states, and we have to find out which states produce X value 1 or X value true. So we'll represent the alarm as X, and we'll make a Boolean expression for X and find out when X is on. So I've sort of written out the problem in a more abstract way, removed a lot of the extra words, and I'm noticing that the alarm circuit is triggered if either of the following conditions are met. So those 2 conditions need to be evaluated and then combined with an OR operator. So we need the top and bottom conditions to be evaluated first and the OR to be evaluated last. So let's analyse the logic of these expressions. How can we simplify it and make it even more abstract? Well, saying that sensor A is on is equivalent to just saying A. And sensor B is off is just the equivalent of saying not B. That makes it even simpler. See if you can create 2 simplified expressions that replace those 2 expressions in the brackets. I'll show you the answer in a moment. So it's A and not B, or B or not C. So we're starting to look like a Boolean expression now. So in order to complete this case study, write this statement using Boolean algebra, make a logic circuit to match the statement, and make a truth table to match the statement. In other words, you're creating the circuit that would be used to control the cryogenic tank, and you're evaluating the truth table for that circuit. Okay, so here's case study 2. I'm going to do the same kind of thing. It's about a rocket launch. So a rocket launch is subject to safety checks. The rocket will only launch if the temperature is above 0 and below 32, the temperature is below 0 and antifreeze has been added to the fuel. So either of those conditions will do, and a logic circuit is used to control the launch process. Draw the circuit and the truth table derived from it. So I'm starting to abstract that down. There are the 2 circumstances under which the rocket can launch. Once again, an OR operator to connect those because either of those can be true. And I'm going to call the rocket launch X. And I'm just labeling the different conditions. There are 3 conditions. So being above or below 0 degrees, being below 30 degrees, and adding antifreeze. So I've analysed that into 3 different conditions that I'm calling A, B and C, and it makes this condition. A and B, that is above 0 and below 32, or not A and C. Below 0, but antifreeze has been added. So there's the expression that we've made, and once again, write this statement using Boolean algebra, make a logic circuit to match the statement, and make a truth table to match the circuit. So I'm leaving you with two tasks. These are the expressions that I've derived from those two case studies. And for each one, you've got to show the expression using Boolean algebra, build a circuit that matches that expression, and a truth table from the circuit. Okay, so I'll check how you're getting on in class. Bye for now.